This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Good morning, I'm Mr. Desilva, a teacher at Irene B. Williams Secondary School in the Geography discipline. Today we're going to be looking at Geography 101. In this case, we're looking at weather and climate. So let's get right on to business. So what's weather? Weather refers to the short-term state of the atmosphere. That's usually up to a week's worth of information. Now, weather is day-to-day in terms of the changes, and things such as temperature, rainfall, and humidity are what are involved. So you're talking about short-term little things that you can record at a met station, for instance. Climate, however, is a general pattern of weather, which can be expected in a location. So things like latitude, distance from the sea, and ocean currents, these types of things are what would influence what the climate is for an area. Now, climate is long-term, and typically a climate of an area is used and judged based on at least 30 years worth of data gathering. So now the elements: temperature, precipitation, wind speed and direction, humidity, barometric pressure, cloud cover, and visibility. So we'll go into those in details right now. Temperature is measured by a thermometer, as we're all aware, and here's an example. Measured in degrees centigrade or Celsius or degrees Fahrenheit. Fahrenheit is what we tend to use in Antigua. So temperature range is basically subtracting the low temperature from a high temperature. So let's say the high was 80 and the low is 60. 60 from 80 gives us 20 degrees. So that would be the range. Now, precipitation, that's any sort of falling moisture. So that's inclusive of rain, sleet, snow, and hail. And if you've never actually seen snow in real life, I highly recommend it, because these snowflakes that they're always talking about, I've witnessed them using a magnifying glass. Now, the rainfall is typically measured in centimeters or inches. In our case, Antigua averages between 43 and 46 inches of rain per year. Barbuda is a little drier, and it's less than 40 inches, or about just over 1,000 millimeters per year. So let's continue. Precipitation. It's influenced by the amount of warmth that's in the area. Even though most of us are not aware, most of the rain actually begins as falling ice crystals. The warmth that's in the air would determine what it ends up as on the ground. So of course, if it's above freezing, it's going to be rain. Or if, let's say, it freezes just on getting to the ground, that's freezing rain. Sleet, which would be the minute balls. And of course, snow, which kind of didn't remelt between leaving the clouds and hitting the ground. All right. So rainfall is categorized by intensity, whether it's heavy or light, and duration. So here's a simple example of what you'd see in CSEC textbooks. So light and intermittent, intermittent meaning on and off, light and continuous, and so on. Notice that the intermittent rain, those are vertically aligned. Then you have other symbols for showers, hailstorm, drizzle, and thunderstorms, and so on. Drizzle tends to be the easiest to remember because of the comma. All right, so here's an example of a weather station diagram. Now these would illustrate the weather conditions that you would see in a location. So there's about 1, 2, 3, 4, 5, 6, 7, 8 different things being represented here on this small diagram. The temperature, 76 degrees Fahrenheit, the air pressure, the wind speed, the amount of coverage of the sky, and the temperature at dew point. So let's say it's at 76 degrees, dew point being 55. That means that it's not raining at the time because there's not enough moisture in the atmosphere. All right, so humidity refers to the amount of moisture that's in the air, and it's measured using a hygrometer or a wet-dry thermometer. So you have two different measuring devices, one of which is in water and the other one is dry. So absolute humidity is basically a measurement. In this case, it's grams per cubic meter. Then you have relative humidity, which is an expression of the present moisture expressed as what is possible, a percentage of what is possible at a given temperature. Absolute humidity is a measurement of the precise amount of water that's in the air at a particular point in time. So let's say we measured 21 grams per cubic meter in this case. Now, relative humidity is taking that absolute measure and putting it as a percentage of what's possible. So let's say the possible at a given temperature is 35, but you're currently running 21. Now pay attention, 21 and 7 are both multiples of 7. So that would be 3 over 5 or 60% for those of us who like our fractions. Wind speed and direction. Now this is measured in knots, in miles per hour or kilometers per hour. Now a knot is about 1.85 kilometers or just over 1 mile per hour. It's measured using an anemometer. This would be the device we're referring to. Now, wind direction can be measured using a windsock. I'm not sure how many of you remember this from beside the airport runway when you're heading towards Carlisle. And then you have a wind vane. All right, so wind speed and direction once again. Now, these projections coming from the circles would indicate the location that the wind is coming from. In this case, all of them would be coming from the southeast. Now, in terms of speed, each one of these shorter strokes would be 5. So let's take a look at this one. 10 would be the longer one. So we have 10, 20, 30, 40, 45 knots. We can use the range, but it's easier to remember 5s and 10s and so on. So this one here would be 50 knots, which is a pretty basic tropical storm. Cloud cover and visibility, that's another one. Now, this Greek word, octas, has to do with eighths. So in this case, completely clear sky is 0, 1, 2, and so on. Notice the 2s, the multiples of 2s, a quarter, a half, 3/4, whole, and so on. So pay attention to this one here that indicates that there's something blocking your view of the sky so you couldn't get a reading. So here's another example of a weather station diagram. The cloud cover, that's 7/8 covered. The air pressure is 998 millibars. Now, typical normal air pressure is about 1013. So this is low pressure in this case, which would probably indicate maybe a developing tropical depression. So here's another one, wind direction. So in this case, it's coming from the southwest. And look, the 2 long strokes. So you're talking about 20 knots. Winds coming from the southwest at 20 knots. Dew point temperature at 68. Current temperature of 77, which this indicates that the combination of these would indicate to you that rain is not currently falling, but it could have been at that location previously. So the present weather, there's thunderstorms, but no showers. Previously, there was a little bit in terms of shower activity. And the trend was that the air pressure has been falling. So in this case, a tropical depression is probably making its way towards that location. So types of clouds, they're typically classified by 2 things. The level at which they're formed, and secondly, the type of weather they're associated with. And of course, the cumulonimbus cloud is probably the most famous one. The big anvil-shaped cloud that starts low level and can go several kilometers up into the sky, usually associated with thunderstorms and tornadoes in North America, for instance, and of course with hurricane and that type of instability. Then you have cumulus clouds. Those are the cute little cotton ball clouds that are usually associated with fair weather. Then you have stratocumulus. Now, basically, when you hear the word strato, it's talking about a level. So a stratocumulus cloud basically covers an area, and it's also associated with continuous rain, sometimes pretty light. Then you have the cirrus clouds. Cirro, generally having to do with high level in terms of altitude. Those are fair weather clouds that you tend to see during the drier periods of the year. So here are a few symbols. So you have the cumulonimbus down here, is kind of shaped like an anvil. Cumulus, so you have the half circle, and the half circle with another circle on top of it. That's showing that the cumulonimbus is vertically building. And here's cirrus again, that wispy high-level cloud that you would see during the dry periods. So now questions. So what's the difference between the highest and lowest temperature for a particular day? Is it A, daily temperature range, B, mean daily temperature, C, maximum daily temperature, D, annual range of temperature? Next question. Wet and dry bulb thermometers are used in measuring, is it A, temperature, B, relative humidity, C, atmospheric pressure, or D, the amount of sunshine. Next, the annual range of temperature. Is this A, the difference between the average temperature of the hottest and coldest months of the year, B, the average temperature of the year, C, the difference between the highest and lowest temperature of a particular day, 4, the difference between the highest and lowest temperatures recorded during the year? So we're going to take a break right now, and then I'm going to come back with the answers.
You're watching Homeschool 101.
So here are the answers to the previous questions. Now, the difference between the highest and lowest temperature of the day would be the range. Remember, I explained that a range is just a difference between two values. So in this case, substitute the lowest temperature from the highest temperature, you get the range. So a wet and dry bulb thermometer, remember I showed you the example and illustrated what was going on. So in this case, relative humidity would be the answer. Annual range of temperature. The difference between the temperature of the hottest and the coldest months of the year. So in this case, it's as it says in the answer, it's a monthly temperature that's to be expected, and the highest and lowest are subtracted. Moving on. So now we're looking at climate specifically now. We've looked at the elements of weather, and now we're talking about influences on climate. So climate is determined by weather patterns, which in turn are dictated by two things specifically, temperature and precipitation. So let's look at this diagram here. All right, so we're looking at the torrid zone first of all. So of course the rainforest would be the wettest areas because there's more moisture to support the plant life. Then you move on to savanna, which you associate with Timon and Pumbaa and Lion King and so on. Then you have desert, where you have a serious, basically a permanent drought, so to speak. Moving on to the temperate areas. Temperate forest, temperate grassland, and now you have deserts, perhaps where the annual temperature ranges are greater, like in the Sonoran Desert in the southwest of the United States. Then of course you have, so notice the temperature is decreasing now. So you have taiga, or you're talking about those, those archetypal Christmas tree type of forests. Those, then you have the cold areas like the Arctic and the tundra. The thing is, even though there's a ton of ice, obviously it's pretty cold. Secondly, most of those areas are covered by permafrost just below, let's say 2 or 3 feet below the surface. So of course, there would not be an opportunity for large trees to grow in those areas. So, all right, so some of the influences on climatic patterns. Distance from the sea, ocean currents, latitude and altitude. Now, here are some examples of some climates. The dark red here, or burgundy if you want to call it that would talk about the equatorial or the tropical rainforest that we know of, where you find the anaconda and the jaguar and so on. Then you have the savanna regions, giraffes, elephants, that type of stuff. Then you have the deserts. Those are some of the ones that we're going to be looking at. Then of course you have those areas where you think of the 4 seasons, like the northeastern part of the United States and southern Canada towards the east as well. So you're talking about the changing birch and oak trees during the fall, the flowers and so on during the spring, the beautiful greens in the summer, and of course the dreariness of the winter. So, distance from the sea. Another term for this is continentality. So in this case, areas that are closer to the sea are moderated by the effects of the sea. Now, one thing about water in general is that it takes longer to heat up, but it retains the water better. Retains the temperature better, rather. All right, so let's look at these two climate graphs. The first one is Toronto, Canada. The second is Genoa, Italy. They're pretty much at the same latitude. One is about 43.4, one is about 44.2, I think. All right, so now this dark line here indicates average temperatures below 0. Notice between January and March, you're below 0, and of course November and December so this is Toronto. So much of the year, temperatures are below freezing. In Genoa, Italy, nowhere do you see anything in terms of freezing. That's the 0 degree line, and here's the red line that indicates temperature variances. So you're talking about temperatures that vary between, let's say, 12 and 26 degrees centigrade, which is about, let's say, the upper 40s to about 73, 74 thereabouts in terms of Fahrenheit. So at no point in Genoa, Italy would you expect it to go below freezing for any point in time. You have extreme instances, but the pattern is the temperatures don't go below freezing. Now look here. So I mentioned 12 to 26. That's about 14 degrees centigrade of annual temperature range. Now let's look at Canada. We're talking about minus 12 to 22. So we are talking about 34 degrees centigrade in annual temperature ranges. So Genoa, virtually all of Italy, is pretty close to the sea. Canada, however, that area of Canada, it's surrounded by the Great Lakes, just away from Buffalo in New York and so on. This area is hundreds of miles from the actual Atlantic Ocean. And therefore, it can't be moderated by the effects of the sea. So that would explain the extremes as compared to Genoa, Italy. So now ocean currents. Now ocean currents, they're either warm or cold and they originate from particular areas. Now the black lines here would indicate the currents that don't move too far from the originating latitude. But now let's look at some of the warmer currents. Here's the Gulf Stream, which would have originated in the Gulf of Mexico, come around the Bahamas and heads towards Northern Europe and Norway and so on, that area of Northern Europe. Now, the result of this is that England and Norway, which are considerably further north than, let's say, New York City or Boston, tend not to have winters as extreme as would be the case in that area that's further south. All right. So, as I said, these cooler currents actually suppress rainfall. So let's look at the Peru current right here. The Atacama Desert is just along this strip of western South America. And because of the colder ocean currents that don't really generate in terms of much humidity and cloud formation and so on, these areas tend to be drier. Like for instance, the Baja Peninsula in Mexico and Southern California and so on, those areas aren't as wet, let's say. And then you have the Namib Desert, which is influenced by the Benguela current coming up north here. All right, so other influences on climatic pattern, so the latitude. Latitude, of course, refers to your position relative to the equator, whether it's in north or south. Now, the fact that the Earth tilts on an axis at 23.5 degrees actually inclines the torrid zone more directly towards the sun. So that would explain why our annual temperature ranges aren't as great as, let's say, New York City or even further north, Moscow and so on. Those areas that are more towards the horse latitudes or increasing towards the poles, those areas have more inconsistent solar energy going to them. And in addition to that, a ray of sun will actually spread out over a greater geographical area in those northern or southern areas. And therefore, they don't heat up as well during their winters. So, other influences on climatic patterns. So we have altitude or the height above sea level. So those of us who are familiar with John Hughes, for instance, John Hughes and Fig Tree Drive, you notice, most likely, that the temperature in town is typically noticeably hotter than would be the case in John Hughes and Fig Tree Drive and so on. All right? Now, one of the reasons is that you have something called an environmental lapse rate. Now, this ranges with the amount of humidity, but I won't explain that because that's A-level type of stuff. All right, so let's say, for example, a height of 5,000 meters above sea level. You might have a temperature difference of 35 degrees centigrade as compared to another area that is at sea level. Now, this is, let's say, for 7.7 decrease for every 100 meters. So now let's look at this little video here.
Hi, my name's Ethan.
And I'm Melissa, and we will be showing you how to find adiabatic temperature change. Before we begin, we should start off with the basics. As air rises over a mountain, it cools until it reaches the top. If it cools down to the equivalent of dew point temperature while rising, precipitation can occur. The windward side of a mountain is over here and generally receives more precipitation, and the leeward side is drier. Adiabatic temperature change is when air spreads out due to low pressure and high elevations. A dry adiabatic lapse rate is descending 10 degrees Celsius for every 1,000 meters you ascend. The wet adiabatic lapse rate, or the area of dew point temperature, descends 6 degrees Celsius per every 1,000 meters. To find the temperature going up the windward side, you subtract 10 degrees Celsius per every 1,000 meters in a dry area and 6 degrees Celsius for every moist area. Going down on a leeward side, you only add 10 degrees Celsius per every 1,000 meters. Now, let's put it in context.
We start out at a temperature of 26 degrees Celsius. Because this is not yet at our dew point temperature, we need to start by subtracting 10 degrees every 1,000 meters. So 26 minus 10, 16 degrees Celsius. Because it's not 6 yet, subtract one more. So it would be 6 degrees Celsius. And now we have reached our dew point. This is when it begins to rain or precipitate. We now go up by subtracting 6 each time. So 0 degrees Celsius minus 6 once again would be negative 6 degrees Celsius. Now that we're on the leeward side of the mountain, we are adding 10 degrees Celsius every 1,000 meters we go down.
Now, it'll stay negative 6 degrees Celsius over here because it is at the same elevation. It's descending 1,000 meters, so you'll be adding 10. So now it is 4 degrees Celsius. Adding another 10 for the 1,000 meters. That's 14 degrees Celsius. Another 1,000, 24 degrees. That'll end at 34 degrees Celsius.
All right, as the video explains, and as I explained before, as you go up, temperatures actually go down. It has something also to do with the amount of oxygen molecules and so on towards the surface and whatnot, but let's move on. All right, so we're going to look at the first major tropical ecosystem.
You're watching Homeschool 101.
Equatorial climates are found between 0 and 5 degrees north and south of the equator. They typically have heavy rainfall throughout the year, and something called the intertropical convergence zone, where you have trade winds meeting, causing uplift and cooling and cloud formation and instability and so on, would add to the already high levels of rainfall. These areas have pretty slight annual changes in terms of temperature. Remember, the equatorial region receives the most consistent amount of sunlight from the sun, and therefore they have more consistent energy levels. So the annual temperature ranges are pretty slight overall. Now, these areas are of the highest biodiversity in terms of plant and animal life, and some of the animals that you're familiar with, anacondas, boa constrictors, jaguars, spider monkeys, tapirs, and so on, will be found in those areas. Now, tropical marine climates. Now, we are actually in a tropical marine climate zone. So for one, they're heavily influenced by the sea, hence the word marine. Those of us who know Spanish, la mar means the sea in Spanish. These areas are also prone to hurricanes. Now, one of the reasons why equatorial zones don't really get hurricanes is that the wind system is not as developed as areas just outside. So the circulation that is necessary for a hurricane to develop would not be found in areas just outside of that. But our tropical marine areas, basically the clusters of storms that come off of Africa are basically funneled into the tropical marine zone, and then they make their way north to carry energy towards the equator. In this case, the wet and dry seasons are pretty distinct, as we're aware of in Antigua. So we're currently in a drought period, so the area looks amber and brown and whatnot. And then come the rains, let's say the end of May, early June, if things are normal. And then you're going to be expecting the place to look green and verdant and so on. So these areas, you have grasslands. Think about Seaview Farm, Gunthorpe's, Lightfoot, that's what you would see. Then dry and wet forests. So think about Fig Tree Drive, that area. Then you have coastal mangrove wetlands, think about South Coast horizons. Then you have scrubland, which is basically low quality trees and scrub. So those areas where you have a lot of cassie and common cherry and tamarind and neem growing about the place, that's basically what you consider scrubland. Tropical continental zones are also called Sudan type or savanna type ecosystem. Sudan would be found somewhere here, a little south of Egypt and east of Ethiopia, for instance. Now, these areas are located between 5 and 20 degrees north of the equator. Now, just like tropical marine zones, they have distinct variances in terms of moisture, and therefore there's a distinct difference between wet and dry season, and even more so than our areas, because in their dry period, there's almost no rain to be expected. Now, the temperature range is slightly greater because they're just a little further away from the equator than our zones. All right, so the vegetation, tall and short grasses, scattered trees, and you have closed shrubland. Not quite forest, but there's a fair amount of woodland in those wetter areas that are closer to the equator. Another rule for you to keep in mind is that the closer you are to the equator, typically the distribution of rainfall is more even and more abundant in the tropical zone because there are other variances outside of the tropics. Now, these areas are homes to elephants, giraffe, meerkat, Timon from Lion King, cheetah, and lions. So take a few moments to look at the table here, which is related to the questions right here. These are snippets from an old past paper that I decided to put in. Now, first question. The annual temperature range shown is A, 2 degrees centigrade, B, 3 degrees centigrade, C, 25 degrees centigrade, or D, 27 degrees centigrade. Next question. The rainfall pattern indicates A, rainfall throughout the year, B, rain only in the cooler season, C, rain only in the warmer season, D, little variation in the rainfall from one month to the next. Next question. The climatic type shown above, so pay attention to the temperature and variances and the rainfall amount and if there's any big changes. So is it A, savanna, B, equatorial, C, tropical marine, or D, tropical continental? Now let's look at the answers. Now, if you guess, or you shouldn't have been guessing, that the answer is B, you would be correct. Remember, temperature range would be the difference between the highest and the lowest figures. So the highest figure here is 28, with 25 being the lowest. So 25 from 28, of course, is 3. So the answer is B. Next one. The rainfall pattern indicates rain throughout the year. A. Now, even though there are variances, you would notice that it's still a fair amount of rainfall. So 155 millimeters of rain, for instance, would be 6 inches, about 5 inches in June, which is still a fair amount, going up to 275, which would be roughly 11 inches, if my memory serves correctly, if my math is working. All right, so the climatic type shown above is, for one, rainfall is high throughout the year, so that's an indication. 2, temperature range is slight, only 3 degrees centigrade, which of course would only point us to equatorial regions, right? So this has been the end of your first Geography 101 session. Next time we're going to come with some human geography topics. Watch out for those.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.